Hello, this is the video for Chapter 1, Lesson 4. Today, we are going to take a look at the distributive property. So this is also a property that you have seen before. And before we kind of go into all the problems, we're just going to review some of the basics here. So if you have these notes, we can go ahead and fill these in together. The distributive property basically is where you have a term outside of a parentheses, and we are going to distribute that into every single term inside the parentheses. So we're going to multiply the number outside the parentheses to each number inside the parentheses. Now, what's a term? A term is a number, a variable, or the product of a number and one or more variables. So an example, right? 2x, or the product of the number and the variable. So 2x or 2xy, that would be a term. So all of these are considered terms. A constant is a term with no variable. So up above, which one of these would be a constant? 2 would be the constant. Okay, so that's a term with no variable. A coefficient is the number in front of the variable. So looking up above, which one has a coefficient? Right off the bat, we can see that 2xy, 2 is the coefficient. Now, there's also another one here that has a coefficient. We just don't see the actual number written down, and that is right here. When there's a variable, when there's like a variable by itself, there's always a coefficient in front, and it's the number 1. We just don't normally write the number 1 in front of it. And so you can always think the coefficient right here, we could see in front of x is 1. Like terms have the exact same variable factors. Well, what does that mean? The word factor, remember factor is think exponents. So like terms would be examples like 4x and 3x, or 2xy squared and 5xy squared. These are all like terms. Now, unlike terms do not have the same factors. So that would be something like 3x squared and 5x to the 4th power. These do not have the same factors, and these are no longer like terms. So even though the variable itself might be the same letter, if it does not have the same exponent, then they are no longer like terms. Let me actually delete everything here. And let's go down and practice some problems. So I'm going to show you after we've distributed. I like to draw arrows, okay? So I like to distribute and remind myself I'm distributing everything what's outside the parentheses into everything inside the parentheses. And so what I have here is 5 times x plus 5 times 7. And to simplify that, it would be 5x plus 35. Here, I'm going to distribute. So I'm going to actually write out the work of what I'm distributing. 12 times 3 minus 12 times 1/6 t. So 12 times 3 is 36. 12 times 1/6 is, if I simplify, is 2. So this becomes 36 minus 2t. Over here, though my number is behind my parentheses, I can distribute it in because it's outside the parentheses and it's being multiplied. So I'm going to distribute it in 3 times 0.4 plus 3 times 1.1c. 3 times 0.4 is 1.2. 3 times 1.1 is 3.3, so 3.3c. I'm going to distribute this in. Now, be careful here because what I'm distributing in is a negative y. So I'm going to show you how this would look. Negative y times 2y minus negative y times 1. Okay, so if I'm looking at this negative y times 2y, y times y is y squared. So now I have negative 2y squared. Then I have a minus and negative. You could look at this as a positive y or a plus y instead. Remember, I don't know if this is a concept you remember from pre-algebra, but when there is a double negative, you can also look at it as a positive. And so what I have is positive y times 1. And so if I have that positive y, also becomes my addition sign. And so it becomes plus 1y, but instead of writing 1y, I'm just going to write y. Another way to look at this is when I have these terms, I often like to circle my operation with the number, with the term, and that now becomes, it takes care of the operation for me. So this negative 1 times negative y, negative 1 times negative y is positive 1y, which equals y. And when I have a positive y, I'm going to write that positive symbol here, and it becomes my operation sign, which is an addition. And then I have a plus y instead. So there's a few ways to look at that visually. There's different ways to kind of tackle this problem. I know these are the most confusing with those negatives, but it's good for us to review. Now, E through H are all ones that have a distributive property where there's negative outside the parentheses. Like we said before, there is a coefficient of 1 whenever we don't see that number. So this is a negative 1 being distributed in. I'm going to put that 1 in with all these negatives so that when I look at these problems, and I'm going to do them in a different color, it is negative 1 times A plus negative 1 times 5. Like I said before, if you look at what you're working through when you're distributing at the term with the operation in front of it, oftentimes that takes care of your operation in your answer. And so negative 1 times positive 5 is negative 5, whereas here we have negative 1 times positive 5. That's negative 5. So negative 1 times A is negative A, and it's plus negative 5. But instead of writing plus negative 5, I'm just going to write this as minus 5. So I don't have two operations going on. So negative 1 times positive 5 is negative 5. If I just write that negative 5 here, that becomes the answer and the final way of writing my operation here. Okay, negative 1. I'm going to now use the method where I'm looking at my terms with the sign or the operation in front. Negative 1 times negative x is positive x. So negative 1 times negative x. And then I'm going to look at this separately as negative 1 times positive 31. And then when I write my answer, I'm going to write the sign that goes with the term, and that becomes the operation. So negative 1 times negative x is positive x. Negative 1 times 31 is negative 31. So my final answer here is x minus 31. Negative 1 times 4x. And then we've got negative 1 times negative 12. Negative 1 times negative 12. Now, when I write my answers, that operation, that sign will become the operation. Negative 1 times 4x is negative 4x. Negative 1 times negative 12 is positive 12. So I'm going to put plus 12. And final one, -1 times -6m. And then I have -1 times -9n. -1 times -6m is +6m. -1 times -9 is +9n. That positive becomes the operation, becomes the addition. Okay, continuing forward. Back to blue here. Algebraic expressions are in simplest form when there are no like terms. So get rid of all your like terms for it to be most simplified. And no parentheses. You got to get rid of the parentheses. That's when you know it's simplified all the way. Let's take a look at combining like terms. So like we said earlier, when there is no number in front of a variable, there actually is. It's an invisible 1, which means when I subtract this, 3y minus 1y, 3 minus 1 is 2, it's 2y as the answer. Question, are these like terms? Yes, they are, because there's the same variables to the same factor with the same factors. They have the same exponents. So here I am going to subtract. I am going to add the opposite because I see a negative here. So I have -7 plus -5. That's -12. And then I'm going to keep my variables mn to the 4th power. Okay, last problem. See, it's not showing up here, but I'd like you to write this down and then do it with me. I'm going to kind of put it up here. 7y to the 3rd power x minus 6 times y times x to the 3rd power plus y to the 3rd power x. All right. Same letters, different terms going on. I'd like you to circle the pair of like terms that you're seeing. It should be this pair and this pair. It's got the same letters, same variables, to the same power in the same spot. So the 3rd power is in between, is with the y. So it's y to the 3rd power, y to the 3rd power. The coefficient here would be 1, which means when I can combine these two, I can add them together. 7 plus 1 is 8. So simplified would be 8y to the 3rd power x. Then I'm going to bring this down because there's no like terms for it to combine with. I'm just going to bring it down, minus 6y x to the 3rd power. And these are not like terms, so I cannot simplify that. And that is my final, most simplified expression for this problem. All right, hopefully this helps. And that's all I have for you today. We'll see you next time. Bye.